Good morning, students. In this video, I'm going to discuss about the concept of pseudo color image processing. So actually, we have discussed two important categories of color image processing at the beginning of this particular topic. We have two categories of color image processing. They are full color image processing and pseudo color image processing. So as we discussed, full color image processing, it deals with direct processing of color images which are obtained by using digital cameras, video cameras, or maybe color scanners. On the other hand, the pseudo color image processing, it deals with assigning colors to the grayscale image. The process of assigning colors to a grayscale image, we call it as pseudo color image processing. You might have heard about many of the old movies converted into color movies. There actually we use the concept of pseudo color image processing. So pseudo color image processing, it is a concept which deals with conversion of black and white or grayscale images into color images. So for pseudo color image processing, we have two important methods. The first method is intensity slicing, or it is also called as gray level slicing. So here in the diagram, we have shown the concept of intensity slicing. It shows the geometric interpretation of intensity slicing. In this method, what we do is we assume the object which is to be assigned with colors as a three-dimensional function, as shown in the diagram. As shown in the diagram, the object of the image which is to be assigned with colors, it can be treated as a three-dimensional function. Then after that, we are going to place a plane parallel to this coordinate axis. If you look at this diagram, here we have x and y coordinates, which is like a coordinate axis we have. On the z axis, we have shown the intensity levels of this particular object. The intensity levels, they lie from 0 to say to 55. We are going to place a plane parallel to this coordinate axis such that this plane is going to cut the object at some intensity level Li. Assume that this is the intensity level Li, where this plane is going to cut three-dimensional function object. Okay. Then after that, suppose if this object is to be assigned with two colors. Now all the pixels whose intensity is between 0 to Li for this object, all those pixels, they are assigned with one color, and other pixels, that is the pixels whose intensity is above Li up to last intensity level, they are assigned with the second color. The pixels which are exactly on the plane, they can be assigned with any one of these two colors. This method we use in case if we want to assign two colors. Similarly, if we want to assign multiple colors to the same object, in that case, we are going to move this parallel plane up and down to have multiple interval of grayscales, so that each grayscale interval, they can be assigned with particular colors depending on requirement. Suppose, assume that you want to assign 8 colors. We are going to divide the intensity of the pixels or intensity axis into 8 intervals, and each interval can be assigned with the required color. So this is the process we use in case of intensity slicing for assigning colors to grayscale image. So here, if you look at this second diagram, the same concept is shown. On the x-axis, you are going to find the intensity levels, say 0 to L-1, and on the y-axis, we have shown the colors, say C1, C2, and so on. Now, all the pixels whose intensity is between 0 to Li, they are assigned with first color, say C1, and the pixels whose intensity is above Li, they are assigned with the second color, say C2. So this is the concept of intensity slicing. Students, next we have gray level to color transformation. So this is the second method we use for assigning colors to a grayscale image. So this method we call it as gray level to color transformation. Here we are going to apply independent transformations on the grayscale image. Assume that f of xy, it is the grayscale image which is to be converted into color image. We are going to perform three independent transformations: red, green, and blue transformations. These transformations may be of any type depending on the application. Even intensity slicing can one of the transformation at these three: red, green, and blue transformations. These transformations, they are going to provide the outputs as f r of xy, f g of xy, and f b of xy. That is the outputs from red transformation, green transformation, and blue transformation. These outputs, they can be given as input to the 3 electron guns of color monitors. So you might have studied that monitors basically they consist of electron guns. They are nothing but cathode ray tubes which work with electron guns. So color monitors, they consist of 3 electron guns, so that these electron guns, they corresponds to the basic colors red, green, and blue. Here the outputs generated from these 3 transformations, red, green, and blue, they are given as input to the 3 electron guns of the color monitors. And this method can be used whenever you want to convert a single grayscale image into color image. But however, if you have multiple grayscale images which are to be converted into color image, we can make use of this particular scheme. So this is pseudo color coding for several monochrome or grayscale images. Okay, if you look at the diagram, the concept is like this. Here we are going to apply different grayscale images, f1 of xy, f2 of xy, f3 of xy. Like that, you might be having k number of grayscale images. This k number of grayscale images, they are applied as input to the different transformations, say T1, T2, T3, like that up to Tk. Each of these transformations may generate the output G1, G2, G3, so up to Gk of xy. These outputs, they are given to the additional processing box, which will generate the outputs as H, R, Hg, and Hb of xy. So this additional processing box, we can think it as a multiplexing box. The grayscale input images which are transformed, they are applied as input to the multiplexing box. So this multiplexing operation may generate the 3 outputs as HR, Hg, and Hb of xy, which can be later fed to the electron guns of the color monitor to produce the composite color images. Dear students, this method can also be used to convert a grayscale video into color video, because basically the video is nothing but a group of images. This group of images which are in the grayscale format, they can be at a time converted into color images, and they can be combined into a video by using this particular concept. Students, this is all about pseudo color image processing. You may expect one question on this topic in the exam, like explain the methods used for pseudo color image processing. You have to explain all the 3 diagrams with their concepts in the exam. Okay, students, I'm going to stop this class. We'll continue in the next session. Thank you very much.